In this video, we'll be looking at the length of a vector that is in component form. So just say we've got this vector here, A, and in component form, it is 2, 3. So that's 2 here, that's 3 there. What you'll see is a right-angled triangle. Right-angled triangle, we're finding the length of the hypotenuse. Well, that brings us to Pythagoras' theorem. And the way we would write that is vector A, and we put it in this form here. It looks like the modulus form. That's because, well, it's a length. It can't have a negative answer. All right? So that would equal the square root of 2 squared plus 3 squared, which equals 4, square root of 4 plus 9, because 2 squared is 4, 3 squared is 9, equals the square root of 13. Now that answer has to be units, because we're talking about a length. We're talking about a length, so it has to have a unit. So we don't know what the unit is, because it's a vector. It could be a velocity, it could be a force, it could be acceleration. We're not sure. There's no context in the question, so we just write units. So if we have vector, for example, P equals 3 minus 5, and we have vector Q equals minus 1, 2, and we've asked to find the length of P, well, we do it the same way as we've done above using Pythagoras' theorem. It's going to be 3 squared plus negative 5 squared, which equals square root of 9 plus 25 equals the square root of 34 units. You must put the units there, okay? You have to do it. Otherwise, the answer is wrong. And in a test situation, if the question's worth 3 marks, you're going to lose a mark. So if we're now asked to find the length Q, it's the same way, using Pythagoras' theorem. So it's minus 1 squared plus 2 squared equals square root of 1 plus 4 equals the square root of 5 units. It's easier to leave it in surd form than to put it as an irrational number. If you can square root it, for example, if you have a number such as 4, 9, 16, 25, go ahead. But in this case, leave it in surd form. Now, if we are asked to find the length of a vector that's P take 2Q, well, before we can do anything, we need to find out what that vector is, P take 2Q, and that's using our vector addition or subtraction in this case, and scalar multiplication that we've done in the past. If you're unsure, have a look at a previous video. So it's P take 2Q. So P is 3 minus 5, take away 2, now Q is minus 1, 2, equals, now minus 2 times minus 1, so that's going to be 3 minus 2, that's plus 2, minus 5, minus 2 times 2 is 4, so it's minus 4. Oh, so that's minus 5 times minus 5 times minus 4. Yep, so I got a bit lost there. 3 plus 2 is 5. Minus 5 take 4 is minus 9. Now, from here we've got our result. We've got the vector p take 2q in component form. Now we can find its length. So its length is, length is 5 squared plus -9 squared equals the square root of 25 plus 81 equals the square root of 106, and don't forget the units. Okay, when it comes to finding the length of the vector, it's just Pythagoras' theorem.